All right, guys, we are going to add to our notebook. So in our lines and angles table of contents, we're going to add page 33 for today. But on 34, we're going to write something similar. So we're just going to add one thing today. We are going to be talking about when our two lines crossed by a transversal are parallel, what happens to all of those new angle pairs that we just discussed. So when lines are parallel. And then I'm leaving a little space here because the next notes that we're going to do on page 34 are similar, and you'll see why once we get to those. So let's turn to 33 and 34. And then it should be the very next one in your notebook or in your packet. So it looks like this. And when you're looking at it on this side, you're going to want to fold it like a book, but backwards, just to that dotted line so that we can see the title. And then if you want to do a cut to get two doors, you can do that. And we'll tape it in. My word, where's my tape? There it is. Okay. So this is one of my favorite things. I love these angle pairs. I just think they're so fun to hop around. And I always kind of call it like a bit of a maze because I almost feel like it's traveling through a door. So like if they make a pair, then I can travel to that next pair. And then I just have to know the relationship of that pair. So when the lines are parallel, a transversal will create those pairs of angles with some special properties. And we talked about them being congruent or not congruent. And so when they're congruent, that's great because I can set up an equation and I can solve for stuff. When they're not congruent, that's not great, but they did have a special relationship in which they were supplementary, which means add up to equal 180. So that's also like a great equation that I can write to help solve for stuff. So congruent just helps me to write the equation where two things are equal. Supplementary helps me to write the equation, add up two angles and set them equal to 180. So when we were talking about our new angle pairs, the ones that were congruent were our corresponding angles, our alternate interior angles, our alternate exterior angles, and really those are the only ones that matter on parallel lines, but I did include a box because when I'm on lines crossing, I always get vertical angles, and vertical angles are equal as well. So the reason I'm highlighting it is because it's always true that vertical angles are congruent. So always congruent, and that's vertical angles. It doesn't really matter if the lines are parallel or not. If lines cross, then vertical angles are congruent. So that's why that's kind of special. Now, with our supplementary angles, really we mostly just talk about our consecutive interior angles or same side. I kind of like same side better. Same side interior angles. But we could also include same side exterior angles. And then like this one here, when two lines cross each other, I always have a pair of supplementary angles, and those are linear pairs. So always supplementary are linear pairs. They don't have to be parallel to be a linear pair. If two lines cross, you don't even need three lines. If two lines cross, you have linear pairs. I feel like I should zoom in a bit here. Boop, boop, boop. That up. Zoom, zoom, zoom. There we go. That's better. I think I can move my face around too. Oh yeah. Hi. Okay. All right. So again, these things are helpful understanding a true math fact about our angle pairs is super helpful because they allow me to solve for variables that I don't know. Now, truly, all of these angle pairs are theorems. So a theorem is a conditional statement that I have proven to be true. You don't need to worry about how to prove it true. We can maybe do those things later if we want to come back to proofs. But essentially, like what each of these theorems says is like, for example, the corresponding angles theorem says if two lines are crossed by a transversal and those two lines are parallel, then corresponding angles are congruent. Alternate interior angle says the same thing. If two lines crossed by a transversal are parallel, then alternate interior angles are congruent. So essentially, if we know the lines are parallel, then we know these angles are congruent, or we know that these angles are supplementary. So we can use those as true facts to do math. So that's what we're going to do down here. So use the theorems to solve for x and y. So if I take a look at where x and y is, like I have a y variable here and I have x variables there, I noticed right off the bat that since I don't have multiple x or multiple y variables, I'm probably going to want to solve for x first. So like if I have a little x equation right here and then another one right there, I want to think about what pair do they make? What kind of pair do they make? And that pair is a vertical angle pair, which are always congruent, which means set them equal to each other. So I would write 2x plus 4. I didn't even need for the lines to be parallel, but I can tell that they're parallel. And I think I mentioned this before, but if you have these little extra arrows on your lines that look parallel, that's them reminding you, hey, these lines are parallel. Kind of like I put the little tick marks to remind myself, hey, these things are congruent, or the rainbows to tell me, hey, these angles are congruent. We put little extra arrows on our lines to remind us that, hey, these lines are parallel. So anyways, they didn't need to be parallel for these vertical angles to be congruent. So I can set 2x plus 4 equal 2x plus 32. And I can solve for x. So I would subtract x on both sides and subtract the 4 on both sides and get x equals 28. And I want us to kind of get in the habit of defending our answers. So I can set these two things equal to each other and solve like this because of the vertical angles theorem. And there you go. But if I want to solve for y, y is a little bit trickier because there's not another y little expression. So I have nothing to like set it equal to, or I don't have anything to add it up to equal with 180. But now that I know x, I could really plug x in here, or I could plug x in there. Now these two are not a pair. But these two are kind of a pair. So they are same side exterior angles. And same side exterior angles add up to equal 180. So if I take 28 and plug it in and do 2 times 28 plus 4, I guess I could have plugged in 28 right there and just bopped it over. Ah, well. That's 56 plus 4, so 60. So I know that this angle right here is 60 degrees. So I can use, oh, I want that green back. I can use this along with my 8y minus 4 as a same side exterior angle pair. So I would add them up to equal 180. So I would do 60 plus 8y minus 4 equals 180. And again, I would do that because 60 and then this angle here are same side exterior angles, which are supplementary. And so then over here, I would combine like terms. I'd have 56 plus 8y. I'd subtract the 56. And we get 8y equals, let's see, 124. And divide the 8. So y is Boop, boop, boop. Oh my gosh, is this not going to go evenly? Did I goof up somewhere? Let's see, 180 minus 56 divided by 8. Yeah, it doesn't go evenly. So 15.5, or, if you want to reduce this fraction, since I cheated and used a calculator, I'll put 15.5. And I can do all this because of the same side exterior angles theorem. So same side exterior angles theorem. Boop, boop, boop. Okay, so let's practice some of these inside. So in this picture here rather, they are showing me that lines C and lines D are parallel, and I can tell because of the little extra arrows on there. And I really have two different transversals I can look at. I can look at transversal A, or I could look at transversal B. But I always want to refer back to the parallel lines. I don't ever want to travel like from A to B. Like I don't want to travel that because these are not parallel lines. Okay, and then they're telling me the measure of angle 1 is 100 degrees, so I always like to add that to my picture. And the measure of angle 5 is 75 degrees. Find the rest of the angles and list the theorem or postulate used. So again, list the reason that you know the angles are what they are. So we're always going to refer back to what's given if we can. So for example, if I start at angle 1, it's 100 degrees because it was given to me. If I want to go to angle 2, I can travel that way because angle 1 and angle 2 are a linear pair. And linear pairs add up to equal 180. And so if this is 100, this has to be 80. If I wanted to travel to angle 3, again, starting with the angle I know, since I know angle 1 is 100, if I travel to angle 3, I can do that because they are a vertical pair, so vertical angles. And vertical angles are congruent, so angle 3 would be 100. Last but not least, on this little corner up here, angle 4 and angle 1 make a pair. They are a linear pair. Oops, shoot. And linear pairs add up to equal 180. So angle 4 would be 80. Now, I can also know that angle 4 is 180 because it's vertical with 2, but I'm just always referring back to 1, and it's not really wrong if you said that it was vertical, but I just always wanted to refer back to 1 because that was the angle that I knew. Okay, so let's try that with angle 5 as well. So angle 5 over here is given as 75 degrees. And if I want to travel to angle 6, I can do that because they are a linear pair. And linear pairs add up to equal 180, so that would be 105 degrees. Angle 7, oh, you know what? I'm going to actually skip the rest of those. I'm going to maybe leave those for you to try. I actually want to jump up to angle 9 because that's actually the way I want it to go. So this is kind of confusing, but I'm going to draw a line through here. So all of these top angles are going to refer to angle 1, and all the bottom angles are going to refer to angle 5. So you're going to see what I mean in just a second. So I was always referring back to angle 1 to say why the angle measured what it measured. So for angle 9, I need to travel to the next parallel line, which is up here. And angle 9 relates to angle 1 because they are corresponding angles. And corresponding angles are congruent. So because angle 1 is 100, angle 9 is 100. So we're always going to refer back to angle 1. Number 10, or angle 10 rather. Angle 10 is not a pair with angle 1, but I can figure out how much angle 10 is. So since I knew that 1 and 9 were corresponding, that makes this 100. So I know that angle 10 will be 80, but we kind of used a couple of things to get there. So we almost did corresponding plus a linear pair. to get there. We kind of had to do two things. I did the corresponding part to get angle 9 at 100, and then 9 and 10 are a linear pair, so that's kind of how I have it. I had to use two pairs. So that's kind of weird. The measure of angle 11. So comparing angle 11 to angle 1, those are alternate exterior angles, and alternate exterior angles are congruent, so this would measure 100. And then angle 12 compares to angle 1 because they are same side exterior angles. And same side exterior angles add up to equal 180. They're supplementary, and so this would be 80 degrees. So the reason I wanted to do that whole top part with you is I'm going to have you guys try the bottom part. But let's jump down here and try these ones. So again, we can use these angle facts to help me solve for variables. So starting with this first one here, I can tell that lines C and D are parallel because they put those little extra arrows on there. And so since they're parallel lines, I can use some angle pairs. Now I noticed that these two right here are a linear pair, but they're not great to use because one has an X and one has a Y. I don't want to use these ones because they're not a pair and also they have an X and a Y, but I do notice that this one here has an X and this one here has an X, and those are a pair. They are alternate exterior angles, and alternate exterior angles are congruent to each other. So I would do 4x minus 16 is equal to 3x plus 14, and I would solve for x. So I'd subtract the 3x, and since x will be over here, I'm going to add the 16. So I'll have 30 equals x. And the reason that I can do that again was because they were alternate exterior angles. Now I also need to solve for y, but again, like there was no other y to compare it to, but now that I know x, I can plug that in and figure out like how much this was because these were a linear pair. So I can do 4 times 30 minus 16. So that'll be 120 minus 16 for 104 degrees. So I can do 104, which is this angle here, plus the 3y plus 2 equals 180, because again, they were a linear pair. So I can almost go put the reason right now. Like I know I'm writing that equation because I have a linear pair. So then when I want to solve for x, I want to combine my like terms. So I'll have 106 plus 3y equals 180. We'll subtract that 106 to get y alone. And so we'll have 74 and then divide by 3, and I feel like that's going to go evenly. Oh, that sure isn't. That's annoying. I'm just going to leave it as a fraction. Y equals 74 over 3. I can tell that it's not going to go evenly because if you add up the digits, like 7 and 4, that's 11. And 3 doesn't go into 11, so 3 won't go into 74. So I'm just going to leave it as a fraction. Fractions are fun. Okay. Last but not least right here. So I can see that lines A and B are parallel because they put those little extra arrows on there, being cut by transversal C. And so I noticed this time that my equations here and here have y's and that one has an x. So I'm going to want to try to make a relationship between the y's, and those two right there happen to be a linear pair because they're adjacent and making up a straight line. So I can do 2y plus 15 plus y plus 30 equals 180 because they are a linear pair. And so then when I want to solve for y, we'll combine our like terms. So we'll have 3y plus 45 equals 180. We'll subtract that 45 on both sides. So 3y equals 135. Oh, and when I divide 3 this time, it will go in because if I add up those digits, 5, 6, 7, 8, 9, 3 goes into 9, so 3 will go into this. Let's see, 45 times So by a linear pair, we can get that y is equal to 45. Now, like the other ones, I don't really have a pair with x, but I could make a pair right here and right here. Those would be alternate exterior, and they would be equal. So I can say 5x plus 8 is equal to this, but I'm going to want to plug the y in so I know how much that is. So we'll do 2 times 45 plus 15. So 90 plus 15 is going to be 105. So we'll set that equal to 105. And again, we could do that because those were alternate exterior angles. And so then if I want to solve, I would subtract 8. And so 5x will be 97. Oh, oof. And then divide by 5, which is not going to go evenly. So it's not going to reduce. I'm just going to leave it as 97 over 5. Cool, cool. All right. See you tomorrow.